Okay, Thursday's worksheet was called Solving Quadratics in Vertex and Factored Form, and it was broken up into three types of problems. Problem 2 and 3 are both equations that are already in vertex form for you, and all you have to do is rearrange to solve. And so I worked both of those because they gave us two different kinds of answers that I wanted to make sure I discussed with everybody. So the steps are actually going to be the same for the two problems. On question number 2, the first step that we would do is we would subtract the 72 to move it to the other side. And so that would leave us with negative 2 x minus 4 squared is equal to negative 72. And then we would divide both sides by negative 2 to move the negative 2 to the right side. And that would leave us with x minus 4 squared is equal to positive 36. And then we would square root both sides, because what we're effectively trying to do is peel the layers. We're trying to move everything away from the x to get x isolated by itself. And when we square root both sides, we need to remember to do plus or minus the square root. And that's because there are two numbers that when you square them, they become 36. So there are two numbers that are the square root of 36. And so you get plus or minus, and then square root of 36 is 6. So it's positive 6 or negative 6. You only have to do that when you are applying a square root to something. If a square root is already in a given equation, we don't have to do that. The sign will already be there. And then the square root eliminated the squared on the left side. So on the left side, all we have now is the x minus 4. Now, technically speaking, the last step to solving would be to take that minus 4 and add it to move it to the right side. When we do that, it'll become a positive 4, and then plus or minus 6. And a lot of the time, the problem would be done. But in this case, it's not completely done because we can actually simplify and finalize our two answers. So our solving is actually done, but we just need to finish it. Our first answer would be the 4 plus 6. So our first answer is 10. And then the second answer would be 4 minus 6, and so we would get negative 2. And so those are the two answers to that quadratic. The question 3 has the exact same steps. That's not the point of doing that problem. So same steps. We would first subtract the 4 to move it to the right side. So that would leave the 1/4 x minus 5 squared, and it's equal to negative 4. And then technically what we're doing next is dividing by the 1/4, but dividing by 1/4 is the same thing as multiplying times 4. And so that is usually how we write it. We would say, oh, I just multiplied both sides by 4, and that's what canceled the 1/4. But it's the same thing. And so that gets the x minus 5 squared by itself, and it gives us negative 16 on the right. And then this time around, when we square root both sides, so we square root the left to get rid of the squared, of course. When we square root the right side, we still need to remember to do plus or minus. But this time there's a negative inside the square root. And so when we square root it, we get plus or minus still, because we did do that. The square root of 16 is 4, and the fact that it was negative makes it imaginary. Makes it an I. And so now when we do our last step and we add the 5 to move it to the right side, and it becomes positive 5 plus or minus 4i, this time we actually are truly done. We can't combine those two terms. And so the only thing we could do, it doesn't actually accomplish anything, is we could write them as two separate answers for 5 plus 4i or 5 minus 4i. But that still doesn't accomplish anything. So that's why I boxed the 5 plus or minus 4i, because usually we just leave our answer written in that format. So that's why I wanted to do that problem as well, to discuss that different format for the answer. The other ones that I did on this side of the worksheet were number 7 and 8, because these two problems, they both were not in vertex form yet, so we had to do the completing the square process. And this is slightly different from when we did completing the square in the previous quadratic unit. Excuse me. because this right here was a y, not a 0. And so we were trying to put our equation in vertex form, and therefore we kept everything on one side of the equation. Because we're now solving, what has happened is this y has now become a 0. And what that means is that when I do the completing the square process, I have the freedom to do stuff on both sides of the equation. So what I did was I treated number 7 as we did it in the first quadratic unit. I did everything on the left side. And then I rearranged. So I didn't touch the right side until it was in vertex form. And then on number 8, I went ahead and I actually manipulated and worked with both sides to show people their options for how to do it. So on number 7, the first thing I'm going to do is I'm going to put it in vertex form. And so if you recall from the previous unit, that means I grouped these two terms together, and I took the a value and I pulled it out, and that a value is that 4 that's in front of the x squared. So I pulled the 4 out, and it may become x squared plus 6x, and then I left a blank right there because that's where I'm going to be completing my square. But I also leave a blank right here because that's where I'm going to be keeping my equation balanced, just like we did in the first quadratic unit. And so what I would do next is, remember that we take this term right here, we chop it in half and square it. So when we chop it in half, it becomes positive 3, and then we square it, and of course it becomes positive 9. And that tells us what number goes right there to complete the square. But then we have to balance our equation right here. And what we need to recall is that everything in this set of parentheses right here was being quadrupled by the 4 out in front of it. So it looks like we added 9 to the left side, but what we actually did was we added 9 times 4 to the left side. So to balance our equation, if we added 36 to the left, we would also need to subtract 36 on the left side. And now the completing the square process is actually done. We're ready to write our vertex form. So we have our a, our 4, out in front. Our parentheses are now a perfect square, and we can factor it as x plus 3 squared. And then the constants at the end right there, they combine to give us negative 20. And it's all set equal to 0. But now it looks exactly like questions 2 and 3. And so now we can actually begin the process of rearranging to solve. So we would add the 20, of course. Same steps as number 2 and 3. So add the 20 to move it to the right side. Divide both sides by 4. Square root both sides. And of course remember to plus or minus when you do that. And that gets rid of the squared over there, just leaving the x plus 3. And here, this time around, we get plus or minus and then the square root of 5, and there's nothing that can be done with it. It can't be simplified. So we leave it as that irrational number, that square root, and then we subtract the 3 to move it to the other side. And so we get negative 3 plus or minus the square root of 5. And so that one is solved. It's done. Okay? And then number 8, same kind of thing, but you notice what has happened is this equation was negative x squared plus 4x minus 85 is equal to 0. Because this is now a 0 over here on the right side, we had the freedom to move the number, and so what has happened is they've taken that 85 and already moved it to the right side. And so really the only difference that's going to make is, number 1, the first step of rearranging to solve is already done for us. Number 2, when we balance our equation, we'll do it slightly differently. But the rest of the process is the same. So technically these two terms right here, they're already grouped. But I'm going to go ahead and put parentheses around them because I need to take that negative and pull it out in front. That's my a value, is that invisible negative 1. And that makes the x squared become positive, and it makes the 4x become negative. And then I leave a blank to complete my square. My 85 is already on the right side, and this time I'm going to balance my equation on the right side as well. And so now I can complete my square. And when I complete my square, this becomes a positive 4 right there. But of course, don't forget that everything in the parentheses was being multiplied by that negative out in front of it. So what we had actually just done to the left side of our equation is we'd actually just subtracted 4. And so to balance my equation, I'm going to subtract 4 on the right. So those are your two options. If I subtracted 4 on the left as part of my completing the square process, I could have come right here behind there, and I could have added 4 right there. But because my numbers were already moved to the right side, I went ahead and I just did the same thing to the right that I had done to the left. And so now what I've got is my negative is out in front, my parentheses are a perfect square, and they factor as x minus 2 squared. And then the constants on the right side now add up to 81. So now the first step of solving is also already done for us. And so now to finish the solving process, we would divide both sides by that invisible -1 that's out front and there, get rid of the negative. So we would have x minus 2 squared is equal to negative 81. And then we'll square root both sides, of course remembering to plus or minus. And that'll get rid of the squared right there and leave us with x minus 2 on the left side. And then the right side will have the plus minus, and then the square root of negative 81 is 9i. And then our last step is to add the 2 to move it to the right. So we have 2 plus or minus 9i, and those are our two solutions. And so that problem is now done. Okay. And then what I did was I did 3 problems from the back. Not because they were terribly difficult, but because they were either commonly missed problems, problems that people tend to make too complicated, ones that could be done a variety of ways, things like that. So for example, number 10, people always forget that the very first thing you should do when you're factoring an equation is you should pull out your GCF. But before I actually do that for question 10, I do want to point out something that I did inform all the classes of that day. One of the biggest, if not the biggest, mistake we see in factoring is that people forget that if you're going to factor an equation to solve it, it absolutely has got to be set equal to 0, because what we're using is something called the zero product property. And what the zero product property says is if A times B is equal to 0, so if two things are multiplied together and they equal 0, then either A equals 0 or B equals 0. And that's the only number that it's true for. So if I have an equation, like if you look at number 16 really quick, if you look at 3x squared plus 5x is equal to 2. Let's say you decide you're going to factor it just the way that it is, and you decide to factor this, but it's still equal to 2. That won't work, because if you factor it and you get two factors, A times B, and it's equal to 2, that doesn't mean one of those actually has to be 2. You could have 1/2 times 4. You could have 1/3 times 6. You could have -1 times -2. But when the two things are multiplied together and they equal 0, one of them absolutely has to be 0. And so that's why we can factor to solve. So on number 10, all it requires to factor it is to pull out your GCF, and your GCF for number 10 is just an x. And so if I pull the x out, it leaves me with an x plus 7. And it was already set equal to 0, so that part was fine. And so now what I've got is this is my first factor, and this is my second factor. And so what the zero product property says is if these two things multiply together to equal 0, that either this first factor is equal to 0 or this second factor is equal to 0. And so that means that x equals 0 actually is one of our solutions, or that means x equals -7 would be our other solution. So on number 11, I'm going to actually do it the same way I did number 10 at one point, but I did want to show you another way that you can do it, because this one doesn't require factoring. This one only has one term with an x in it at all, and so I can just rearrange it to isolate x like I did the problems on the front. So I'm going to divide both sides by 4. That moves the 4. And so I have x squared is equal to 9/4. And then I'm just going to square root both sides. And of course, I still have to plus or minus, just like I did before. And so when I do that, that gets rid of the squared over here, gets x by itself, and then I have plus or minus. And then to square root 9/4, I just do the square root of 9, which is 3, and the square root of 4, which is 2. And there's my two answers. But I can do that problem like I did number 10, as far as factoring. I mean, I don't have to, I'm not going to do it with a GCF, but as far as factoring. So I can factor it. Factoring requires that I get it set equal to 0, so I would have to take the 9 and subtract it to move it to the left side. And then once I do that, I have a special factoring pattern. I have a difference of 2 squares. So remember that when you're factoring a difference of 2 squares, that you take the square root of the first term, so the square root of 4 is 2, the square root of x squared is x, and then you take the square root of the second term, which is 3, and then just one of them gets a plus and one of them gets a minus. And so this is my first factor, and this is my second factor, and they're multiplied together to equal 0. And so when I take the first factor and set it equal to 0, I get -3/2 as my solution. And when I take the second factor and set it equal to 0, I get x is +3/2 as my solution, which are the same two solutions that I had up here. It just actually took more work to factor. So just don't think factoring is always the best method. Okay? And then the last problem that I did is one where I'm actually going to factor it with a GCF again, but I'm going to do it the right way, and then I'm going to point out the reason why I wanted to do this problem, because it's one of the most missed questions all the time. So once again, remember, I'm going to factor it. So I want everything on one side so that it's set equal to 0. So I'm going to subtract the 27x to move it to the left. And then I can factor it just by pulling out my greatest common factor, which in this case is a 3x. And when I pull out the 3x, I'm left with x minus 9. And it's equal to 0. And so here's my first factor, and here's my second factor. And if I take my first factor and set it equal to 0, then it gives me a solution of 0. And if I take my second factor and set it equal to 0, I get a solution of x equals 9. Okay, so there's your two solutions to this one. But the reason I wanted to go ahead and do it, even though it was so simple, is because one of the most common mistakes that we see, other than of course not setting it equal to 0 when you want to factor, is that we see a lot of people who go, oh, wait a minute, there's a 3 and an x on both sides, I'm just going to divide that 3 and x away. And so they just divide, and they end up with x equals, and then those x's cancel, and then this divides and gives them 9. And so what has happened is they literally, truly have thrown out this entire half of their equation and their solutions. All they've given me is one of the solutions to that quadratic. So if it's a quadratic, it's got to have two solutions. So I don't want people to think that they can do that. Okay, so that's it for this worksheet, and then let me know if you need me to do the couple of problems we did on tomorrow's worksheet as well. Thanks.